Hey y'all, and welcome to the next module in the Practical Packet Analysis online course. This one's all about network latency. Now, when we talk about latency, what we're really concerned with is high latency. And that means that communication is slow. It means that something is taking a long time to get somewhere, and that's really gumming up the works. Generally, we want things to be very fast when we're talking about network communications. Specifically, when you're looking at things at the packet level, generally we're measuring things in terms of milliseconds, a very tiny amount of time that's almost indistinguishable between the packets that are being transmitted. And that's especially the case when we talk about things like TCP, which have automatic acknowledgement of packets being sent, which require very minimal amounts of processing. So it's really highly dependent upon the network to get packets back and forth in a quick manner so that our applications don't slow down. So those are the things we're really going to be focused on in this particular module is network latency, figuring out why it exists, where it's located, so we can do something about it. Now, the first thing we're going to start with is TCP, and we're really going to focus mostly on TCP in this section because TCP is the transport protocol that is used when we're concerned about reliable delivery of data. So it has all kinds of great error recovery features built in, things like retransmissions, duplicate acknowledgements, and flow control mechanisms via the TCP receive window. So we're going to go through all three of those. I'm going to talk about them a little bit in theory. I know I hit on those a little bit when we talked about TCP in that dedicated section earlier. But we're going to talk about those specifically as it relates to latency in this section. And I'll hit on the theory, and then I'll actually show you some packet captures with examples of each of those and what it might look like when you're experiencing some type of high latency scenario. So we're going to focus mostly on TCP. We're not too concerned about UDP since UDP is an unreliable protocol in the first place. Noticing gaps in UDP communication is usually pretty easy. It's just a simple matter of looking at large time windows between two different packets, and that may work fine for UDP, but TCP is a little bit more complex and requires a little bit more know-how, and that's why we're going to focus on that. Once we talk about those different TCP error conditions, I'm going to talk about how you can locate the source of high latency when you're looking at TCP transported data. So I'll introduce a framework for how to do that, so how you can look at the first few packets within a TCP capture and determine where the source of latency probably is. Once I've introduced that framework and gone through some examples, you'll have an opportunity to practice this on your own. So I actually have lab exercises with examples of latency, and I'm going to give those to you, and you have to tell me where is the latency. Is it with the client? Is it with the server? Is it probably with something in between those two things? So you actually have to diagnose this yourself, which I think is a pretty fun exercise. Finally, I'll talk about network baselines. Of course, if you think something's slow, it helps to know what it looks like when that thing is fast. You want to be able to compare and contrast those things. So creating a baseline, very important to diagnosing latency, among a whole lot of other reasons. So with that said, I think this is a pretty fun section. Even if you're focused on programming or security, this is pretty cool because it helps you learn a little bit about slow and fast network communications and how to contrast the two, and that's pretty neat. So with that said, let's get going.